In this lesson, we are going to be learning two different ways to divide polynomials. One of them is polynomial long division, and the other one is called synthetic division, which is a bit of a shortcut where we don't have to write out all of the same steps, but either will work for your polynomial division questions. Okay, so method one. Polynomial long division. So those of you who learned long division in school, this is going to be maybe a bit easier. If you've never done long division before, I will take you through the steps. So, example. Okay, what we're going to do is we're going to divide 6x cubed plus 5x squared minus 1 by x plus 1. So how many times does x plus 1 go into 6x cubed plus 5x squared minus 1? So what we're going to do is we are going to set this up in a classic long division sense. What we're dividing in goes on the left. We have our division symbol, and then we are going to put 6x cubed plus 5x squared. Here is a bit that is a little different. So we don't have a 0x written here, but we are going to write a 0x here. We need to list all the powers of x, including the ones that are not represented. List all powers of x, okay, all the way to the constant. So we need, if there was no constant, we'd have to write plus 0 because we want to get a constant piece, and that's where we're going to end up. Okay, so what we're going to do is we are going to look just at this first number, the x, and we're going to ask ourselves the question, how many times does x go into the first term? Where x times what equals the first term? Well, x times, if we want to get 6x cubed divided by x, we get 6x squared. Okay, so now what we're going to do is we have 6x squared. We're going to multiply 6x squared times x plus 1 in brackets. So we have to think about x plus 1 being in brackets. So 6x squared times x is 6x cubed. 6x squared times 1 is 6x squared. Okay, and we're going to do a plus here because it was positive. Now, we're going to put this in brackets and we're going to subtract it from what comes above. Okay, so we figured out how many times does x go into 6x cubed. We wrote down what that was. We multiplied it back by what we divided in, and now we are subtracting to see what's left over. So 6x cubed minus 6x cubed is nothing. 5x squared minus 6x squared is negative x squared. Now I'm going to bring down my next term. So negative x squared plus 0x. Okay, this is really similar to what we're doing when we're doing a regular long division, except instead of x's, we have powers of 10. So when we bring down a 5, we know that that 5 is, it could be 5 tens or 5 whatever, depending on the place value. With polynomials, we don't have place values, so we represent that using our powers. Okay, so now we have x, we're going to take it into the term we have down here. So we're going to say, how many times does this x go into negative x squared? Well, x times negative x gives me negative x squared. So I'm going to write minus x. Notice I'm writing my answers above the powers because I want to know when I want to stop. So if I'm doing polynomial long division, I need to have this last term over here. Right, we don't have anything lower than a power of 0 for x. So that's where I actually want to have my last term be. So that's why I'm writing the x squareds over the x squareds and the x's over the x's, just to keep track. So now I have minus x, so I'm going to multiply minus x by both things inside my bracket. So minus x times x is minus x squared. Minus x times 1 is minus x. And then I'm going to subtract this, so minus x squared minus x squared is 0, as it should be. This first term should always be 0 because we should be dividing this first term, the x, evenly into the negative x squared or the 6x cubed or whatever we were working with. So now we have here 0x minus x, which is just plus x. And now I'm going to bring down my minus 1. That's the last term I have, so this is the last division I'm going to do. So here I have x plus 1. How many times does that go into x minus 1? Well, I just look at how many times does x go into x. X goes into x plus 1 times. So 1 times x plus 1 is x plus 1. Then I'm going to subtract this. X minus x is 0, and minus 1 is going to be negative 2. And generally, we're always going to be having a numerical remainder when we're dividing here. Okay. Sometimes we may have an x plus 1 or something if we're dividing by a higher power than x. But if we're dividing by a power of x, where it's just a regular x and not like an x squared, should have a remainder that's a number. Okay, so this is my remainder. So x plus 1 goes into 6x cubed plus 5x squared minus 1. 6x squared minus x plus 1 times with a remainder of minus 2. So there's two ways we can actually express our solution. Okay, so one way is as a product. So if you express the solution as a product, what you're going to write is you're going to write that the thing that we started with, 6x cubed plus 5x squared minus 1, is equal to the thing I was dividing, which was x plus 1. I'm going to zoom out just so that you can see kind of the whole problem a little bit. So that's x plus 1 times the answer, 6x squared minus x plus 1, with minus 2 left over. Okay, so that's your remainder. We can also say, well, let's divide both sides. We can show it as a quotient with a fraction added on. So the fraction generally is whatever you're left with divided by what you were dividing. So that would be 6x cubed plus 5x squared minus 1 divided by x plus 1 is equal to 6x squared minus x plus 1 minus 2, but over x plus 1. So that's what you get when you divide. So there's that sort of extra 2 because x plus 1 doesn't go in evenly. And so when we're doing polynomial long division, this works for any answer, so any dividing any binomial or trinomial in where it doesn't actually factor to that. So we can do it and get a remainder, and we couldn't do that before. Synthetic division, sometimes if we don't have a remainder, the interesting thing is that that means that that polynomial is a factor. The binomial or trinomial you're dividing into your polynomial is actually a factor. So you could factor that out and see what you have left, and then the answer you get is what the other piece of that factor is. So you just get a product. So this can be a tool if you end up with no remainder to help you factor. So we're going to actually do it with the same problem so that you can see the difference. In your book, there is a page where how you get from method 1 to method 2 is gone through it. It's actually pretty interesting if you're able to do it. So method 2 is called synthetic division. Okay, so if you say, well, it's easier, it's quicker, it's faster, what are the drawbacks? So synthetic division. It is simpler and faster, but there is a but. It only works when dividing by x minus a. So the coefficient of x must be 1. Coefficient equal 1. So you can only do it with a coefficient of 1. There is a way to get around that, which we'll show you with the next example. So example 1 of here, we're going to just use the same division that we used before. We're going to divide 6x cubed plus 5x squared minus 1 by x plus 1. Same division problem. Okay? So what we're going to do is we're going to draw a little box over here in the corner. Okay, and in that box, we are going to write the thing that makes x plus 1 0. So we're going to write minus 1. And I'm just going to call this the 0 of x plus 1. So it's actually the opposite thing that we're writing in there. We're not writing plus 1 even though it says x plus 1. So we're thinking of it as x minus a. Now we're going to write in just the coefficients. So 6, that one went with x cubed, and then we have the 5, that one went with x squared. We do still need to write in the coefficient of x even though that term isn't written, so that would be a 0, and any missing term would get a 0 coefficient. And then we write in our constant term, which is minus 1. And you keep the sign, as you can see with the minus 1, you keep the sign with the number. So you consider minus to be a negative. Okay? So now, this is actually super straightforward. So, first term, first number comes down. We get a 6. Now we multiply the negative 1 times 6 and put it up. So we get negative 6. And then we're going to add these two together. So 5 plus negative 6 gives us minus 1. Okay. Now we're going to multiply the minus 1 times minus 1, put it up here, and then we're going to add these together. 0 plus 1 is 1. Okay. And then we get here, minus 1 times minus 1 is minus 1, and we add these together. So instead of subtracting, you're just adding. So you're multiplying and then adding, multiplying, adding, multiplying, adding. What you have underneath your constant term is going to be your remainder. And then these are your coefficients of the quotient. And because we've lined them up, okay, it's always going to be dropping the power by 1. So right here we've got our x, and that's going to be 1 here, x squared minus 1. And sorry, this is x squared, x, and then your constant term. So then we're going to write it out. So your quotient is 6x squared. Note the power has dropped by 1 from the x cubed, minus x squared plus 1. And if we go back and check what we had before, that is exactly identical to what we got before with a remainder of 2. And you could write it the same. I'm not going to go through both different ways to write it again. You can always go back in the video and have a look at that. Okay, so example 2. Well, what if we want to use synthetic division? Does seem a lot faster than polynomial long division. What if we want to divide by something that is not does not have a leading coefficient of 1. So let's look at what happens if we want to divide 4x cubed plus 11x squared plus 9x plus 3 by 2x plus 1. So let's say we wanted to divide that. Okay. Well, what we're going to do is we are going to factor out a 2. So let's think just a little bit before we start. Okay, what we're doing is we're doing 4x cubed plus 11x squared plus 9x plus 3 divided by 2x plus 1. So what I can do is I can think of this as 4x cubed plus 11x squared plus 9x plus 3. You guys know I care because I just wrote that polynomial out twice. I'm going to show it to you real step by step here. This is the same as 2 times x plus 1/2. So what I'm going to do is I'm going to divide by this piece first, and then I'm going to divide everything by 2. You could also divide your polynomial by 2 first, and then divide everything by the x plus 1/2. It's really up to you. I usually choose to do that first, and then divide everything by 2 at the end, so I don't have quite as many fractions to work with through the entire process. Okay, but it is truly up to you, because multiplication is commutative. Doesn't matter which order you're dividing by those two things. So we're going to do our synthetic division on just doing the polynomial divided by x plus 1/2. So we're going to write out the coefficients. We have 4, 11, 9, and 3. Okay, so our 4 is going to come down. 4 times -1/2 is -2. 11 plus -2 is 9. 9 times -1/2 is -9/2. Adding them together, we get positive 9/2. 9/2 times -9/2 times -1/2 is -9/4. So negative 9 over 4, 3, if we think about that, that is 12 over 4. So 12 over 4 minus 9 over 4 is 3 over 4. So this is my remainder. And then these are my coefficients. So if I want to think about that, right? So now what I have is I have that 4x cubed plus 11x squared plus 9x plus 3 over 2 times x plus 1/2, okay, is equal to 4x squared, that's my coefficient of the x squared from here, plus 9x, that 9 comes from here, plus 9/2, that comes from here, okay. Now I have a remainder of 3/4, so that is 3/4 divided by x plus 1/2, so that's 3 over 4 times x plus 1/2. We're dividing or multiplying by 1 over is the same thing. And now I'm going to divide all that by 2 and clean up my fractions. Okay, so if I'm dividing by 2, I'm also, same thing as multiplying the denominator by 2. So we're going to look at 2x squared plus 9/2 x plus 9/4 plus 4x plus 2 divided by 2 is 3 over 8x plus 4, because we're instead of dividing by 2 again, we already have a fraction. Let's multiply by half, and let's keep my notation from just kind of running off into the air here. Okay, so that is how we would deal with it if we have a coefficient in the front. If you're trying to divide by a quadratic, you're going to want to factor and do one at a time. Generally, it's easier to divide by a binomial than by a quadratic. You can divide directly by a quadratic using polynomial long division, but it's not recommended to do that. If you're going to use synthetic division, it has to be a binomial, and the degree has to be 1. It's got to be x minus a. Only way you can use that nice, easier little bit of trick.